Hey everyone, and welcome to a deep dive exploring something I know a lot of you are really interested in.
Yeah.
The search for planets that might be even better for life than Earth.
Yeah, these are what we call super habitable planets.
Super habitable planets.
We're going to take a journey through the galaxy to explore 5 potential candidates.
5.
KOI 4878.01,
Okay.
KOI 456.04, also known as Kepler 160e, Kepler 186,
Got it.
Kepler 442b,
Yeah.
and Kepler 62.
That's quite the lineup. Let's jump right in. What I think is so cool about this is that it really challenges how we think about life. You know, we just assume Earth is the standard for life.
Yeah.
But what if there are planets out there that are even better at supporting life?
Yeah, it really is a humbling thought.
It really is.
And it makes you wonder what's out there.
Yeah, exactly. So let's start with KOI 4878.01.
Okay.
This one is located about 1,075 light years away, and it's been getting a lot of attention because it's one of the most Earth-like planets that's been discovered.
Right, and the Kepler telescope.
Oh yeah, Kepler.
Yeah. Kepler detected it back in 2015.
Okay.
And what makes KOI 4878.01 so interesting is that it orbits its star every 449 days.
Oh wow.
So a bit longer than an Earth year.
Okay.
But here's the key. It's in the habitable zone of its star.
Now when we talk about the habitable zone, what does that actually mean?
Well, we're talking about that just right distance from a star,
Okay.
where the temperature's not too hot and not too cold,
Right.
so liquid water could exist on the planet's surface.
Which is a pretty big deal.
Yeah, it is.
Because as we all know, liquid water is considered to be essential for life as we know it.
Yeah, for sure. I mean, it acts as a solvent, enables all sorts of chemical reactions that are necessary for life.
So the fact that KOI 4878.01 could have liquid water, I mean, that's a big deal.
Absolutely. Absolutely. And there's more to it, too. It's also slightly larger than Earth and may have a slightly higher average temperature.
Okay, so help me visualize this. So a slightly larger, warmer Earth. What are the implications of those differences? Could it make the planet even more habitable?
Well, a larger planet might have a stronger gravitational pull, which could allow it to hold on to a thicker atmosphere.
Okay.
And a thicker atmosphere. That would mean better insulation, regulating temperatures more effectively, and even greater protection from harmful radiation.
So it's like a shield.
Yeah, like a planetary shield safeguarding potential life.
That is so fascinating. Now, you mentioned a warmer average temperature.
Yeah.
How much warmer are we talking?
So based on current data, the average temperature might be just a few degrees warmer than Earth.
Okay, a few degrees.
Yeah, and this could actually expand the habitable zones on the planet's surface, leading to more diverse ecosystems. But we do need more observation to confirm all this.
Of course. It's a delicate balance, isn't it?
It really is.
Too hot, the planet becomes a scorching inferno. Too
Wow.
cold, it's an icy wasteland. But, this slightly warmer scenario that you're describing sounds pretty ideal.
It is intriguing, isn't it? And it kind of gets to the core of this whole concept of superhabitability, where a planet might have certain characteristics that make it even more conducive to life than Earth.
So Earth might not be the ultimate paradise after all. Okay, let's move on to our next candidate, KOI 456.04, also known as Kepler 160e.
Right.
This one's about 3,000 light years away and orbits a star that's really similar to our sun. And get this, it receives roughly the same amount of light as Earth. That's incredible.
It is, especially considering it's only about half the size of our planet.
Oh, wow.
That similar light level is what makes it so interesting to scientists.
Okay.
It suggests that the planet's surface temperature could be just right for liquid water. You see, the amount of light a planet receives from its star is a crucial factor in determining its habitability.
Right.
It's the primary source of energy that drives the planet's climate and weather patterns.
So even though KOI 456.045 is smaller than Earth, it could still be in the running for superhabitability. But what are the challenges of being a smaller planet in terms of supporting life?
Well, smaller planets tend to have weaker gravitational pulls, and that can make it harder to hold on to an atmosphere, and an atmosphere acts like a blanket, trapping heat and regulating temperatures. Without a sufficient atmosphere, a planet can become too cold and inhospitable for life as we know it.
So size matters.
It does.
even in the vastness of space.
Absolutely. And it's not just about finding a planet in the habitable zone. It's about finding a planet that can hold onto its atmosphere, creating a stable environment for life to flourish.
Absolutely. And that's why each new exoplanet discovery is so exciting. It's a chance to put together the pieces of the puzzle of habitability and understand, the incredible diversity of worlds out there.
Yeah.
Beyond our own solar system.
Yeah, it really is amazing.
It is amazing. Well, I'm ready to keep exploring those worlds.
Me too.
Our next stop is Kepler 186, discovered in 2014. This planet is located 580 light-years away, and it's generated a lot of interest because it's in the habitable zone of its star and receives a similar amount of sunlight as Mars.
Okay.
What I find really interesting about Kepler 186f is that it takes 130 days to orbit its star.
Yeah.
This relatively short orbital period suggests that it might experience seasons,
Right.
similar to Earth.
Like imagine a planet with changing seasons, maybe even with distinct weather patterns.
Seasons on another planet. I'm no expert, but I thought Mars had seasons too. And it's not exactly teeming with life. So what makes Kepler 186f so special?
You are right. Mars does have seasons, but they're much more extreme and definitely less hospitable than Earth's. The tilt of Mars's axis, combined with its very thin atmosphere, results in really dramatic temperature swings and harsh conditions.
Okay.
Kepler 186, on the other hand, is thought to be more Earth-sized and may have a thicker atmosphere, and this could create more moderate and potentially life-friendly seasons.
So it's about finding that sweet spot again.
Yeah.
Cool.
Not too extreme, not too harsh, but just right for life to thrive. And speaking of potentially harsh conditions, let's talk about Kepler 442b. This planet is located about 12,206 light-years away, slightly larger than Earth, and might even be rocky.
Kepler 442b. Well, this one's fascinating because it travels around its star in just 112 days.
Wow.
That's incredibly fast.
That is fast, yeah.
And because it's so close to its star, scientists believe that it might be tidally locked.
Now, I've heard about tidal locking, but I need a refresher. What exactly does it mean, and how does it affect a planet's habitability?
Okay, so tidal locking happens when a planet's rotation is the same as its orbital period. In other words, one side of the planet always faces its star,
Oh, wow.
experiencing perpetual daylight, while the other side is in darkness.
So it's like a planet with a permanent day side and a permanent night side.
Exactly.
That sounds pretty dramatic. What would that kind of contrast mean for life? Well, it would definitely present some challenges. Imagine a planet with one side constantly bathed in the intense heat of its star, while the other side is perpetually frozen.
Right.
Those extreme temperature differences would create some very harsh environments.
Yeah, it's really hard to imagine life as we know it surviving in those conditions.
Yeah.
So would the planet be uninhabitable?
Not necessarily. Some scientists think that life could potentially exist in a narrow twilight zone.
Oh, interesting.
Between the scorching day side and the freezing night side, this twilight zone might have more moderate temperatures and potentially even liquid water.
Okay, so a twilight zone teeming with life. That's pretty amazing.
Yeah.
It seems like even the most extreme conditions can't totally rule out the possibility of life.
Yeah, life finds a way.
It really does. All right, let's wrap up part 1 of our deep dive with our final candidate, Kepler 62f. This planet is in the Lyra constellation. It's about the same age as Earth, and the outermost of 5 planets orbiting its star.
Okay, what makes Kepler 62 really interesting is that it could be rocky, or covered in oceans, or even icy.
We don't know.
We're not totally sure yet, but each possibility opens up a whole new world of what kind of life could exist there.
Oh, for sure.
Yeah.
So we've got a planet that's roughly the same age as Earth, potentially, with a variety of surface features, and located in a relatively stable position in its solar system. That sounds pretty promising. What else makes Kepler 62f a good contender?
Well, like Kepler 186.5, some models suggest that it might have an Earth-like climate.
Oh, wow.
Yeah. But, as always, more observations are needed to confirm these early findings.
It seems like every time we discover a new exoplanet, it raises more questions than answers. But isn't that kind of the beauty of exploration?
I think so.
Venturing into the unknown, pushing the boundaries of what we know, and constantly expanding how we think about the universe.
It's truly amazing what we're able to do now.
It is truly amazing.
Mm-hmm.
Well, we've just started our journey through these 5 planets. Stay tuned for part 2 of our deep dive, where we'll delve even deeper into the idea of superhabitability and explore how these candidates measure up.
I'm looking forward to it. It's kind of crazy to think that we've only scratched the surface of what makes a planet super habitable.
I know, right? We talked about, liquid water, being in the habitable zone, the right kind of star. But I feel like there's got to be more to it. What else makes a planet even better for life than Earth?
Yeah, you're totally right. There are a bunch of factors. For example, we always focus on stars like our sun, but some scientists think orange dwarf stars might be even better for life.
Really? Orange dwarfs, what makes them so special?
Well, even though they're a bit cooler and smaller than our sun, they live way longer, like
Wow.
billions of years longer.
Wow.
This extended lifespan could give life on a planet orbiting an orange dwarf much more time to evolve.
Ah, so it's about giving life the time to do its thing.
Yeah, exactly. Time to flourish. It makes sense that a longer-lived star would be more stable for life to develop.
Totally. What else is important?
Well, size and mass are big ones. A planet that's a bit larger and more massive than Earth could have a stronger gravitational pull, which would help it hold onto its atmosphere longer.
So it's like a protective blanket.
Yeah, keeping the planet's atmosphere from escaping. What about the planet's surface? Do you think that's important?
I would think so.
Absolutely. Like, picture a planet with more land and a wider range of geological features.
Okay.
This would create way more habitats and resources for life to evolve.
Oh, yeah, I see what you mean. Like oceans, mountains, forests.
Exactly.
That does sound like a pretty sweet setup.
Right. It would be amazing. It would be a paradise for life. Those different landscapes would mean all sorts of crazy life forms could evolve.
I bet. Anything else we should consider?
One thing that's often overlooked is a planet's magnetic field. A strong magnetic field is like a shield, protecting the atmosphere and surface from harmful radiation from the star.
So like a planet's own personal force field.
Yeah, deflecting those harmful rays.
Wow. Finding a super habitable planet really does sound like hitting the jackpot. It takes a lot of things going right.
It does. It's like a perfect recipe.
It makes you wonder, with all those criteria, how do the 5 planets we talked about stack up?
That's the big question, isn't it? We're still learning about these planets, but we can make some guesses. Let's start with KOI 4878.01. Remember the one that's a bit bigger than Earth and warmer?
Yeah. You said that its size could help it hang on to a thicker atmosphere. Could that make it extra habitable?
It definitely could. A denser atmosphere would create a more stable climate, and a slightly warmer temperature could actually mean there are more habitable zones.
Huh. More habitable zone. So bigger might actually be better in this case.
Right. What we might see as a problem on Earth could actually be good on another planet.
That's really interesting. What about KOI 456.04, the one that's half the size of Earth but gets the same amount of light? Is being smaller a bad thing?
It's hard to say for sure. Its smaller size could mean a weaker gravity and a thinner atmosphere.
Right.
But the fact that it gets the same amount of light as Earth means it could still have a good temperature.
So it's kind of a wild card. We need more info to know for sure.
Exactly. What about Kepler 186, the one with the possible seasons? Do you think it could be super habitable?
I don't know. It sounds promising.
It does. Kepler 186 is a special case because it orbits a red dwarf star. And red dwarf stars are the most common type of star in our galaxy.
Oh, wow. I didn't know that.
Yeah, they're much smaller and cooler than our sun, so their habitable zones are closer in.
Wouldn't that mean the planet would be tidally locked like Kepler 442b?
Maybe, but not necessarily. Kepler 186 is further from its star than a lot of red dwarf planets, so it might avoid getting locked. And if it does have seasons, that could create a more dynamic environment for life.
So many factors to think about. It's pretty mind-blowing.
Yeah.
Speaking of tidal locking, what about Kepler 442b? With its permanent day and night sides, does it have a chance?
It's a tough one. Tidal locking does present some challenges, but some scientists believe that life could exist in that twilight zone, between the extremes. Maybe life could adapt to those conditions, evolve in ways we can't even imagine.
It's humbling to think about that. Like, our understanding of life is so limited.
It really is.
There could be entire ecosystems out there that we wouldn't even recognize as life.
Yeah, for sure.
Okay, what about our last contender, Kepler 62? What do you think?
I think it has a lot of potential. Its age, similar to Earth, suggests plenty of time for life to have evolved. And because it's the outermost planet, it might be less exposed to radiation from its star.
It sounds like we've got a pretty impressive group of planets here. But I gotta ask, is there such a thing as too good? Could a planet be so perfect for life that it actually holds it back?
That's a great question. Some scientists believe that a planet with too many resources and perfect conditions might actually hinder complex life.
Really? I'm not sure I understand. Why would perfect be bad?
Well, think about it. On Earth, life had to overcome challenges and adapt to change.
Right.
That's what drove evolution and led to the diversity of life we see.
So it's like, what doesn't kill you makes you stronger. Are you saying a perfect planet might make life kind of lazy?
It's a thought. Without having to adapt and overcome things, life might not develop the resilience to reach its full potential.
Wow. A planet so hospitable that it actually stops complex life from developing. It really makes you think differently about what a perfect planet is.
Yeah, it does. And it reminds us that we're still learning. As we explore more exoplanets, we're bound to find more surprises, things that challenge what we think we know.
That's what makes it exciting. This deep dive has been amazing. We've looked at planets bigger than Earth, smaller than Earth, planets with possible seasons, and planets that are tidally locked.
We've covered a lot.
We have.
Well,
And we've just started to explore what superhabitability really means.
yeah.
And the idea that there could be planets out there that are even more suited to life than our own planet.
Yeah, and there's still so much more to learn.
Exactly. So let's move on to how scientists are actually finding these superhabitable planets and what tools they use. Okay, so we've got all these amazing planets that might be even better for life than Earth. But how do we actually find them? How do scientists look into these far-off parts of the galaxy?
It's kind of like we're space detectives, trying to find clues from really far away. One of our best tools is the James Webb Space Telescope. It's a total game changer for studying the atmospheres of these planets.
Oh, the James Webb Telescope. I've heard so much about it. What makes it so special for studying these planets?
Well, it's got all these advanced instruments that let us figure out what exoplanet atmospheres are made of, like really precisely.
Wow.
By looking at the light that goes through a planet's atmosphere, we can see the fingerprints of different gases.
Okay,
Things like oxygen, methane, and water vapor.
hold on. So you're telling me we can tell what gases are in the atmosphere of a planet that's light years away?
Yeah, pretty amazing, right?
That's incredible.
Yeah.
But why are those gases so important? Why those ones?
Well, they can be signs of life, at least life as we know it. For example, oxygen is made by plants here on Earth through photosynthesis.
Right.
So if we find a lot of oxygen in a planet's atmosphere, it could mean there's something alive there.
So it's like we're looking for these tiny signs of life in this giant universe.
Oh.
Are there any other missions or tools coming up that you're excited about?
Oh, yeah, definitely. There are a few new missions coming up that are specifically designed to find and study exoplanets.
Ooh.
Missions like Plato, that stands for Planetary Transits and Oscillations of Stars,
Gee.
and Ariel, Atmospheric Remote Sensing Infrared Exoplanet Large Survey.
Wow, they really had fun with that name.
Yeah, but these missions will give us tons of data on the size, mass, and atmospheres of thousands of exoplanets.
It feels like we're entering this whole new era of discovery, like a golden age of exoplanet research. With all this new data, do you think we'll actually find proof of life on another planet, like in our lifetime?
It's possible. The fact that we're finding so many planets suggests that life might be way more common than we thought. And as our technology gets better, we're getting closer to being able to spot those tiny clues of life.
I can't even imagine what that would be like. To know there's life out there, it would change everything. How we see ourselves, our place in the universe. It would be huge.
It would be a huge discovery. It would make us rethink everything we thought we knew about life. But even if we don't find actual proof of life anytime soon, the search itself is still super important.
That's true. Every new planet we discover, every time we study an atmosphere, every piece of data we get brings us closer to understanding all those amazing worlds out there
Yeah.
and the potential for life beyond Earth.
Yeah, absolutely.
It's all about exploring and discovering, trying to answer one of the biggest questions humans have ever asked. Are we alone?
It's a big one.
It really is. Well, I'm feeling pretty inspired after this deep dive. It's been awesome to travel across the galaxy and think about planets that might be even more livable than our own. What's the main thing you want our listeners to take away from this?
I think the most important thing is that we're really just getting started with exploring exoplanets. This is an incredible time of discovery, and we have no idea what we'll find next.
It's a good reminder to keep looking up at those stars, keep asking those big questions, and to never stop exploring. Thanks for joining us on this deep dive into the world of superhabitable planets. Until next time, keep exploring.